All right, so I'm going to do a couple more graphing ones. Just since we only got to do 2 together yesterday. So graph the direct variation equation. So 18, y is equal to negative 3/2 x. So I'm going to go ahead and set up a graph. So my y-intercept is where? Yep, at 0 at the origin. So right there. And then my constant of variation or slope, okay, I'm going to use those words interchangeably, but tells me that I need to do what?
Down 3, right 2.
Yep, down 3, right 2. Down 1, 2, 3, 1, 2. And 1, 2, 3, 1, 2. And with these ones, I would still like you to have 3 points, but if it ends up going like way off your graph or something, it's not that big of a deal. Don't worry about it. Just at least get 2 points on there, obviously. Let's see. Let's look at one more of the graphing ones. 20. So this one is 10y is equal to 25x. So it's not ready to graph yet. Do you know what I need to do?
Divide 10 on both sides.
Yep, so I'm going to divide by 10. So I'm left with y over here. 25 and 10 can reduce down to what?
5 over 2.
5 over 2. X. And then now I can take that and graph like normal. So my y-intercept is at 0, 0. And then what is the slope or constant of variation telling me to do? Up 5, right 2. 1, 2, 3, 4, 5. 1, 2. This is another one's going to go way up here. 1, 2, 3, 4, 5. 1, 2. So since this one is such a big one, like if you just got the 2 points on there, that would be okay. So is the graphing kind of making a little bit more sense now that we went over the homework problems and stuff? Okay, good. That's another reason I want to make sure I give your quizzes back, because it seemed like there's a little bit of issue with our slope, with the graphing the slope.
I'm just confused on
So
does it say 3x? I get the fraction ones, but I don't get the.
So anytime there's just a whole number, so let's say we had like y is equal to, well, you said it, let's just do that. So 3x. Then what we do, make a small graph over here. So we still have our y-intercept at 0. And then what this is, the way that I would do this is when you see a whole number, do that.
Yeah, I was thinking.
Yeah, because that way you remember, like, it's still rise over run. So it's like up or down, and then, well, in our case, we've always been going right just for the sake of it. But, so that would just tell you you're going to go up 3 and then right 1. So I would almost always, anytime you see a whole number, whether it's a negative number or a positive number, go ahead and write it over 1.
I was just going to ask that.
Yeah, that's totally fine. So it would be up 1, 2, 3, over 1, up 1, 2, 3, and over 1. So it would look like that.
Okay.
Okay, well, if I can connect my dots, that would be great. So, yeah. And if it was negative, obviously it would just be going down instead. But it would do the same thing. All right, so this next stuff, it gets a little bit harder just because it's a multi-step thing. But it's not really any kind of like math that you haven't done before. It's just more so applying it. So these say, given that y varies directly with x, that means that we're going to end up having an equation of y is equal to ax. It says, use the specified values to write a direct variation equation that relates x and y. So what we have to do first, let me focus this in a little bit, is we're going to have to find our constant of variation first. Okay, they give us an x and a y value, but they don't tell us what a is. So we have something like 30. Okay, and so they tell us that x is equal to 2 and y is equal to 26. So we want an equation that shows that y varies directly with x, meaning that y is equal to ax. And obviously, normally when we've done these problems before, like up here, y is equal to some number times x. So I don't know what that some number is, so I need to find it. So I'm going to plug in to this equation 26 and 2 for y and x. So it'll be 26 is equal to a times 2. And then I just want to get a by itself. So what would I need to do right now to get a by itself? Yep. So I'm going to divide by 2. And if you prefer to write the number in front so that it says 2a when you're solving initially, that's fine too. But either way, it means the same thing. So then the 2's cancel over here. So I have then that a is equal to 26 divided by 2 is what?
13.
13. So now this is the constant of variation. It wants the direct variation equation. Okay, so this is step 1. So then step 2, we plug this number in, and so we just get y is equal to 13x. So this is the final answer you'll see in the book, okay, and what you're ultimately trying to find. But you can't do this until you have found this, okay? So then 32, we have x is equal to 15 and y is equal to -5. So we always start with y equals ax, and I need to solve for a. So I'm going to plug in the number. So -5 is equal to a times 15. So then what do I do? Divide by 15, and -5 over 15 reduces to what?
1 over 3. -1 over 3.
Yep, -1 over 3. So that's, again, the step 1. So then my final equation would be what?
Y equals -1 over 3 x.
Yep. Let's see. Let's do 34. X is equal to -18. Y is equal to -4. So I'm going to, again, y equals ax. I'm going to plug in these two numbers to solve for a. So I have -4 is equal to a times -18. So divide by -18. So -4 divided by -18 would reduce down to what?
-2 over 9.
Yep. Just positive because they're both negative, so it'll become positive. But yes, 2 over 9.
I didn't know the other one.
Yeah, it's kind of attached, so it's kind of hard to tell. There we go. All right, so then my final equation would be what?
Y equals 2 over 9x.
Yep. All right, I'm going to let y'all try this next one by yourself, and then we'll go over it. I think that's kind of the last thing that we're really doing in this section. So x is equal to -6, y is equal to 15. So take a minute and try that one. just like one sticking out. Still kind of is, but not as bad. All right. What do we get?
Y equals negative 5 over 2.
Times x, yeah. Yep. So we had y equals ax. So we had 15 is equal to a times negative 6. Divide by negative 6. So that reduced to negative 5 over 2. And so then y is equal to negative 5 over 2 times x. So, pretty simple. All right, so I'll add on a couple more to what you had. Let's see, we stopped at 15, I think. So let's do 19 and 21. So those ones are going to be ones for graphing that require you to like either divide or to subtract something over before you do anything else. And then for these that we were just doing, let's do 29, 31, 33, and 35. And we'll go over those tomorrow.